right, week 32 Wednesday solving for H. So the first thing we're going to do is get rid of the constant thing that's not touching a variable. So it's not a coefficient, it's just a number by itself. And since it's positive, we're going to need to do minus 12, and that will eliminate it. So we're also going to do minus 12 over here, which is going to leave us 14. So 7h, which is what we have left now, equals 14. So now we can divide by 7, which gets rid of the times 7. Divide 14 by 7, and h is equal to 2. So now we just plug it in and check. 7 times 2 plus 12, and that's going to be 14 plus 12, which is going to be 26. So smiley face for us. Number 2. We have a minus 16 we're going to get rid of because that's the number by itself, our constant, the first thing we want to do. So we're going to add 16 to eliminate the negative 16. So by doing an opposite of something, you get rid of it or cancel it out, which means we're going to add 16 over here. And that gives us 8 and a 5, 58. So 2y equals 58. So now I would just divide by 2 to get rid of the times 2. And that leaves us y. And 58 divided by 2, 25, and 25 is going to be, so 29. So now we plug it in and check. Let's do 29 times 2. There's our 58. And let's subtract the 16 from the original problem. And bada bing, bada boom, 42. So we're going to do our conversion of units here using the proportion that 1 foot is equal to 12 inches. Now remember, inches is the smaller unit, so we will take more of them to equal the same distance of this lesser amount of feet. So since we have 192 inches, we're going to need a smaller number to get to the bigger unit, so we're going to be dividing by the 12. So a 1 goes here, which is 12, leaving us 72, which is 6. 16 feet is equal to 192 inches. And we have some more fun computer glitches. I have no idea what this is. We're just going to say that it's supposed to be meters and the 1 doesn't exist. So I'm just going to go 4 meters and say it is not to scale. Whatever you chose it to be, just know that the formula for volume of a rectangular prism is length times width times height. So we would have 140 times 4, which is 560 cubic meters, because we're doing a 3-dimensional meters times meters times meters. So remember, mean absolute deviation, or MAD, is a 2-step process. You could even call it a 4-step process, but it depends on how well you understand the mean. First thing is to find the mean. So we have to add all of these numbers together, like so. And then we're going to take that sum and we're going to divide it by how many numbers there are. So since we have a mean of 17, we're now ready to begin step 2, which is to find the MAD. So we're going to create a new list using this list and our mean. How far apart is each number from the middle? So 14 is our first number, right? How far is 14 from 17? 3. How far is 15 from 17? 2. How far is 19 from 17? 2. And how far is 20 from 17? 3. So you'll notice it doesn't matter if they're less than or greater than 17. It's simply how far away. It's at distance. So these are always positive. And now we're just going to find the mean of these. So we're going to add those together, which is 10. And then we're going to do 10 divided by 4, because there's 4 numbers, and that's going to give us 2.5. So our mean absolute deviation is 2.5, or 2.5. So here we have another glitch. We're going to assume this is a rectangular prism. I'm sure you were able to figure that out. So scratch, 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 scratch. There is my beautiful, terrible rectangular prism. And we're looking for surface area, which is not volume. So remember our surface area formula. You may want to write this down, right? Is you're going to do this is for rectangular prisms, 2 sets of the length times width. And you're going to add that to 2 sets of the width times height. And you're going to add that to 2 sets of the length times height. And that gives you the areas of the front and back. Or I think this right here is the base. Length and width gives you the bottom and the top. Width and the height gives you the right and the left. And then length and height gives you the front and the back. And because you have to put all 6 sides areas together to find the surface area. So let's just do, I'm going to zoom in here. We have 6, 6, and 8 as our amounts. So here we go. Okay, so here's what I went through. I wrote down that it's 2 sets of 6 times 6, which was length and width, plus 2 times 6 times 8, which was width and height, plus 2 times 6 times 8, which was length and height, which is 6 times 6 is 36, 6 times 8 is 48, and then 2 times 36 is 72, 2 times 48 is 96, and then when you add those together, you get your final answer of 264, and it is square feet, because surface area, again, it's just a bunch of combined areas. We're never multiplying more than 2 things. We're always just doing the length times width, or the width times height, or the length times height. So we're still sticking with feet squared as our unit. So for surface area again, right, we can write surface area. We're going to do 2 times the length and the width. So here's our, we'll call that our length. We'll call this our width, right? That's going to be 3 times 2. All right, then we're going to be adding that to 2 sets of our width and our height. So that's going to be the 2, and then the height over here is 1. That's our height, right? And then we're going to add that to 2 sets of our length, which is 3, times our height, which is 1. So now we just continue this by solving the multiplication. So it's 2 sets of 6 plus 2 sets of 2 plus 2 sets of 3. Now we can go to the second to last part. 2 sets of 6 is 12. 2 sets of 2 is 4. 2 sets of 3 is 6. And so now we just add those together. 12 plus 4 is 16, plus 6 is going to be 22. And then our label is going to be inches squared, because again, it's just a bunch of areas combined, so the total surface area is still the same measurement unit. Okay, formula for area of a triangle is base, that's a B, that's not a B. There we go, base times height divided by 2, or 1/2 base times height. So we're going to have 3,000, that's 30 times 100, and divide that by 2. So that's going to be 1,500, and that's yards squared. So if we're going to cover the driveway with asphalt or concrete, we are going to need to know the area of it. So we can do something like this, right, and break it into 2 rectangles and find the area of each and then add them together. So we have a 14 by 4 rectangle right here, which is 28 by 2, which is going to be 56 yards squared. And now we use the information we have to find the missing side. So if the top is 14, and this section of the top, which is opposite, right, is 10, that means this leftover section here is 4. So now we know that the bottom side and the top side of the one we drew in is 4 yards. It's hard to write that small. And we know that the whole length is 19, but minus this section of its opposite, which is 4, would leave us 15. So this is obviously not to scale, but this is a 15 times 4, which is 60. Definitely not to scale. So we have 60 plus 56, which is going to give us 110 plus 6, so 116 yards square is the area, and that's how we can figure out how much asphalt we would need. And remember, a ratio is just a relationship between two things. So 12 being that the boys were listed first represents how many boys there are, and 11 represents how many girls there are in one class. So if we were to find a total, that would be 23 total kids. And so what we can say is that 12 to 11 is the ratio of boys to girls, because for every 12 boys, there were 11 girls. And there's no way to simplify that because 11 and 12 cannot be divided by the same factor other than 1, of course, and that doesn't change anything.